Get started. This section here is very, very light on slides. I think I have 4, maybe 5 slides, and one of them is an agenda slide. So I'm going to show some infrastructure that we're going to build the VNF Asterisk stuff on top of, but this is infrastructure that's going to be a virtual machine, instantiate a few virtual machines, and then deploy a Kubernetes cluster on top of it, along with distributed storage for the purposes of running persistent volumes for VNF Asterisk. So I'll get a couple diagrams and then we'll run through, and then I'll fake it to make it while we wait for 10 minutes for it to run. And this is where I'm hoping that you guys will have a little more interaction. We can look at the repositories, we can get access to some of the to the GitHub repo, and we can point you at that. We can look at the code. We can kind of do whatever you want. So this is where I expect you to interact. So if you're writing an email, finish it up and write along. So there's really 3 steps that I'm going to be executing here with Ansible. There's initially deploying the virtual machines. There's installing Kubernetes on top of that and getting a Kubernetes cluster up and running. And then provisioning storage, and we're going to be using GlusterFS as the distributed storage backend, and then fronting that with Heketi, which is an API system that manages the dynamic creation of the persistent volumes from Kubernetes and exposes it to Kubernetes. So this is the diagram of what we're building. 10 minutes from start to finish. I timed it last night. 10 minutes and 12 seconds or something from scratch. So I'm going to go through. I know this diagram is incredibly dense, and I'm going to kind of try to go through what I discovered. So Doug spent a bunch of time kind of working through some documentation and understanding how to get this up and running. I then kind of took all his stuff and his automation and tried to do a deep dive to try and understand what is actually happening in the back end. So I'm going to step back a little bit before we go into all of this. With Kubernetes and containerization, just containerization in general really, there's kind of this separation between the application and the storage and the networking. So this is where you get your compute, you get your storage, and you get your networking concepts, those 3 main interfaces when you start going into a kind of a cloud-native solution. So trying to get your head wrapped around where I can have, say, something like MySQL or Postgres or any other database, and that application can just go away at any time. You can just delete it, it can go away, and you can reinstantiate it. And part of that is understanding that, well, if my database can just go away at any point in time, what happens to the data? Where does it go? Like, if I can just throw it away at any given time and I can just have different pods show up in different locations and they can be distributed across different physical nodes, where does all that data go? So there's this concept of having something like a persistent volume in Kubernetes. Docker has the same types of concepts and stuff like that, where your storage, your block storage, is separated from the application. So the data that the application generates or that it needs to read from is pulled out of effectively another container. And so it's there. You have this concept of having things that are totally separated. So what is being generated and produced and read storage-wise and data-wise is handled entirely separately. The lifecycle management of that data is different from the application. In a virtual machine, they tend to be a little more tied together, where you have a virtual machine, it has a hard drive, like a virtual hard drive in it, you run your operating system on it, you install your application from Yum or DNF or whatever you're using, and the files are written onto the same file system technically, or typically. And while, yes, you can have network storage, you can have NFS, and you can kind of back it that way, in containers, that separation is just like a given. That's just how it works. Your application is not a virtual machine. It's not an operating system. It's taking a very small component that would normally run on top of an operating system and breaking them into these very minute chunks and having them all entirely separated. So when you start doing that and trying to manage things and distributing the storage and having that storage mechanism distributed across multiple nodes, things get a little more complicated. And so you have these layers. So I kind of tried to understand what's happening at each of the layers and what's happening when I, as an operator that instantiates an application, requests some storage for my application. What happens? How does that happen? How does that get instantiated? How does that get done in the lower levels? So at the bottom of this diagram, I have kind of this red bar. It might be hard to see, but there's 3 blue blocks, and each of those are representing a bare hard drive. So that's the operating system on bare metal, or in this case, a virtual machine, where I have dev VDB, so virtual drive B. And so that's just a bare drive, and that has no partitioning or anything on it. It's just the drive. It's been instantiated. So I have a virtual hard drive that has nothing on it. So then we layer that with LVM, and LVM is probably familiar to most people who are using Fedora or something like that, where it's logical volume management, yes, I believe. And so what happens is you can have multiple physical devices, or in this case, virtual physical devices, and you can have one or more of them. So it allows you to scale out your partitions independent of the physical hardware. So I have basically a volume group. So I have a group of disks. In this case, I have one disk. I have a one-to-one mapping. I could add more disks and then extend my partitions on top of that. And so I have a volume group, I have one physical drive that's part of this volume group, and then I have 3 blocks on top of that. So if you look at the first node, the very most left node, and I have like that orange block and then 2 blue ones, each of those are logical volumes, and those are effectively representing a partition, or in this case, just a block of data that I can then consume. So then within GlusterFS up a layer, when I get into GlusterFS, these are effectively called bricks. And so a brick is, like, you can almost visualize a piece like a brick. And that brick is holding the data. And so when I just start distributing across the nodes, I can do something kind of like what you would do with RAID. But in this case, I'm replicating the data. So I have 3 bricks, and each of these bricks are then consumed under GlusterFS as a volume, and that volume is exposed to an operating system, to an application, to Kubernetes, whatever you're using. So when I write to any one of these bricks within this volume, or when I write to this volume in particular, that data is replicated across the network, and that data is written into each one of these bricks. So effectively, I have 3 copies of the same piece of data. So I write into the volume, and GlusterFS deals with distributing across multiple nodes. And that's all done via the network. And so I have this replication. They could also be done in a distributed manner where 3 bricks, if each of these bricks is 1 gig, I could have 3 gigs of data in this volume, and it would effectively stripe across the disks or whatever. In this case, I just want highly available, that if one of the nodes goes away, that data continues to exist in the network and can be consumed from the application. Questions so far?
So you don't lose data in caching? You put your operating system in a journaling mode?
Sorry?
To keep from losing data in caching, you put your operating system in journaling mode?
So the question is, do I put the operating system in journaling mode? And I don't know. I mean, whatever the default is for the operating system, which I think if you're using, journaling, like a ext4 or XFS or something is just inherently journaled.
That's quite a good question.
I don't want to answer because I don't know.
Yeah.
I know that it works, but in terms of understanding exactly how that like that's a fairly technical question, and I just haven't deep dived in enough to answer it. It's a very good question, but I just honestly don't know.
And this also definitely highlights one of the aspects that we're trying to explore with VNF Asterisk is to find these gaps. On our team, we have some experts in service assurance and fault tolerance, and we're hoping to work with them further in the future to look at some of these things that may be, human life critical kinds of things that happen in telecommunications, and something like that where if you miss a write, it could be a cascading problem for you.
Mm-hmm.
So we've started to do this deep dive on GlusterFS, and we understand some of this at a bit of a higher level, but that's the kind of stuff that we really would like to drill down on. So
those are the types of things that you need to understand before you go to production, and unfortunately we're not there yet. So great question. If you find the answer, please let me know. So what we'll be deploying in this infrastructure, we have the 3 nodes. Those are going to represent 3 virtual machines, and then the master, the Kubernetes master at the top, is the 4th virtual machine. So we're going to deploy 4 virtual machines. They're going to run CentOS. Then we're going to install Kubernetes onto the 3 nodes, along with Kubernetes acting as the master on the 4th node. And then we'll be deploying LVM, which we'll have in there. We'll have GlusterFS across the nodes, and then we'll instantiate, we'll basically create some persistent volume, create a persistent volume in Kubernetes, and we'll see that get scheduled somewhere, and Heketi will spin it up for us, and hopefully we'll see everything. So maybe we should explain what Heketi is.
So, just to back up real quickly,
please.
There is a lot of complexity here in this diagram and all of the moving pieces, but in the end, what we're really trying to do here is we want to simply say to Kubernetes, I have an application and it requires storage, and it requires this much. It requires 100 gigs. And then that way, using this kind of intent-based model that we were talking about earlier, is we can say, hey, we need 100 gigs, and Kubernetes can say, hey, where can I allocate 100 gigs? And in order to do that, it uses storage driver, which talks to Heketi.
Yep.
And Heketi is an API that fronts GlusterFS. So given the storage driver, Kubernetes can ask Heketi, hey, do you have a spot for this 100 gigabyte store? And then we can use it in our application. So at the user level, what you're basically going to say is you're going to create some YAML and for a Kubernetes resource definition. You're going to say, I need 100 gigs. And then it's going to do this. But we, in order to further dive into this, we've started to do a deeper dive here. And there's still more to go. But we've been really happy with GlusterFS and how easy it's been to use, and it basically does what we've asked it to do so far, and for that we've just been a fan.
Yeah, it's been pretty reliable in its deployment and stuff like that, which is nice. What was the other thing I wanted to talk about? That's fine. I'll come back to it. So I kind of want to explain a little bit. So Doug had talked a little bit about this before, where he mentioned how we can't use services in Kubernetes for Asterisk because of it being effectively TCP only right now. So when we deploy the storage here, what happens is across the nodes we use something called a daemon set. And a daemon set is effectively a way to say that every node should have this pod because it's effectively acting as a daemon. It's acting as a piece of critical infrastructure to support the applications on top of it. So in this case, our daemon set is GlusterFS, and we say we want to have GlusterFS running on every node in Kubernetes to support and provide a storage backend. So then, in order to front GlusterFS with an API that Kubernetes can consume, we then utilize a deployment. And a deployment is basically just a term that says I want to deploy something, and it's a template. And the way it does that is via a replica set. And a replica set is one or more services that run across and get scheduled on the node. So in this case, our replica set is 1. And so what you're defining is saying what I want the infrastructure to be. And Kubernetes tries to make sure that the infrastructure satisfies what you're intending for it to be. So if a node goes away, so let's say this node that's running the Heketi service, it crashes. The hard drive dies, you pull it out of service, the power goes out or whatever. Kubernetes is going to say, oh, the Heketi service went away, and I need to always have 1, and right now I have 0, so I'm going to reschedule another Heketi service and make sure that's instantiated and it's put onto another node. Now what happens is with the Heketi service itself, this green box and the endpoint and the IP and address, so the IP address of the pod itself, of the Heketi container, can change. And that's really annoying when you're running an application. You just want to say what the DNS address is, or even what its external IP address and what port it is. And so with the pods that can potentially move around and get rescheduled, because what could actually happen is this node could get overloaded, and it may say, this node's overloaded, I actually need to move the pod somewhere else. I need to move it to another node that's actually better balanced, or if I want to rebalance all my workload or whatever, like potentially that Heketi service could move to another node. So instead of having to update my application to say, oh, this address changed, or to have to go and update my DNS and it's cached and it's all out of date, well, what we use is a service. And basically Kubernetes deals with exposing the outside interface and then redirecting it to where the pod actually lives on the internal network. I think that's really, I think that's the gist of it, of what's the most important here. So, see, not very many slides. Let's run a demo. Let's see what happens. If I have a network. Okay, so ignore some of the other virtual machines that I have in here running, because this is actually my home virt host. So right now I have it deployed. So I have kubemaster, node 1, 2, and 3. So what I'm going to do is run for 10 minutes. It's going to tear down the virtual machines. You're going to see the virtual machines come back up. You're going to see Ansible go back in and run the kube install. And then when the kube install is done, it's going to run GlusterFS across that, instantiate the pods. Unfortunately, you're not going to see all this magic stuff happening kind of in real time, but this is what's actually going to happen, and we can just talk about it, and we'll deep dive into some things, and we'll let it run in the background for a bit. But let me get this started. I'm already in it. That's why.
So what Life is using here is a project of ours we call Cube CentOS Ansible. And it's basically a quick way for us to run just an upstream vanilla Kubernetes. And we have this on GitHub. And maybe while it's running, we can bring it up and get you guys the links to that stuff.
Yep. So I'm going to just time it just for fun. But what I'm going to run, so it's actually being done in 4 individual steps. So I'm running an Ansible playbook against an inventory, which is my virt host, and in this case it's remote. I'm running the virtual machine teardown play. I'm going to run the virtual host setup, which is just going to instantiate the virtual machines and get them all up and running CentOS and any dependencies that are required, in this case like Vim or Nano or anything that's just required. And then there's another separate run that happens. So during that virt host setup, it dynamically generates the inventory for the virtual machines so that you can basically connect to that in your next play, so that you don't have to like manually update the virtual host, the virtual machine inventory list. So that's all generated for us. So we'll pass that in, and then we'll run the kube install YAML, and then we'll run the Gluster install YAML after that. And assuming that I don't have any network problems, in 10 minutes, we will have that diagram that I just showed you. Oh, I failed. I I don't know why. No, not quite. I think this is going to complain at me. Just make sure I can actually get there. That doesn't look right. Am I getting redirect?
Are you going to port 2222?
Oh, I know. Yeah, I'm going to the wrong one. Okay, I can still definitely get to the vert host. Oh, I killed the session. That's why. Okay, I'm gonna ignore the timing then.
Yeah.
So I'm just gonna go here, and so that's the repo that we'll look at in GitHub. And so Ansible, if I can type, Ansible playbook, inventory vert host remote, and then I'm going to run the VM teardown. I'm going to run the vert install. Actually, you know what? Let me just
vert setup.
Yeah, vert setup. Sorry. Let me just make sure that it's going to work. Looks like it's connecting now. So we should see these machines start to pop offline here in a second. They're being shut down. All right, cool. So our teardown worked. Perfect. There's our output showing us that we've destroyed all the VMs, undefined them, removed the spare disk image, and then because there's actually a separate, the VDB part, the second hard drive, we instantiate one of those and then attach it into the virtual machine.
Something quick to just mention here is you'll notice that we're using virtual machines, and you might be asking yourself the question, well, why are you using virtual machines if there's an advantage to containers here? And really the answer is because this is convenient to spin up in a laboratory environment. It really wouldn't be too different if you were spinning this up on bare metal. So these playbooks also support spinning them up on bare metal. But we like to test and look at it as a cluster. So if we're just bringing it up to take a look at it casually, we'll just use the virtual machines.
Yeah, I have actually gone through, so Doug will do the work and make sure it all works across like virtualization and running it in VMs. And then I've got some bare metal small nodes that I run at home, and I usually kind of circle back around on it and iterate to make sure that it will deploy on bare metal as well. Not that it's intended for production, but it's always nice to see that you can actually run stuff against bare metal. So assuming that the third node comes up here, we got master, node 1, node 2. That's probably just taking a second.
Yeah.
Hopefully I'm not out of hard drive space. There it goes. I don't know why it's not showing. Could just be slow because of the SSH, but it's definitely connecting to node 3.
Yep.
I don't know why it's not showing up here though. That's weird. It didn't fail, so it's definitely there. Okay, so we've got the virtual machines. That's the most important part. That's all that matters right now. So then we'll run Ansible, playbook, inventory, the generated file, and then we will run our cube install. And so right now we're using Docker as the container runtime.
Yep.
And but it also supports Cryo, which is an alternate CNCF sponsored container runtime. And so Doug's actually done a bunch of work where he's been able to work with Builda and Cryo and use that runtime in order to back Kubernetes with a runtime that's not Docker, more as an experiment to understand what's possible and not possible. So in the future, you can potentially run all of this without running Docker at all and actually using Foundation-sponsored development environment.
Right. So I would say, if you're new to containerization, definitely take a look at Docker. There's a lot of community support for it, but also keep your eye on the horizon for some stuff from what's called the Open Container Initiative, OCI. And there's container runtimes and tools that work without Docker. So, this, the landscape does change.
Oops. Oops. Red Hat NFEPE. Right? Oh,
Red Hat.
I have typo in there because I was going to type mine. All right, so there's, sorry for the small text, but it's github.com/Red Hat-NFEPE is the main place here. We've got a few different things that we've been working on under the NFEPE team, but what we're most interested in right now is the Kube CentOS Ansible, which is what I'm running right now. And so here's the repository, and there's some detail here of what's going on and what the playbooks are intended to do, and what it's doing. There's some information about how to run this. There's some configuration you need to do in the group vars and the host vars files to get everything up and running. So we can look at mine of how I have it set up because I just have a vert host, but there's some information about using Cryo and using Fedora, but that's not what we're doing here today.
Yeah, also linked in there, there's some blog articles that run you through a step-by-step on how to run that. So if you're not familiar with Ansible, it should put you into a spot where, show you how to modify the inventory and run the commands. But it's a low barrier to entry for Ansible for this particular project. And if you already are an Ansible user, you'll find it pretty
straightforward.
Simple, yeah.
Good blog site, blog.nfepe.site, which is where the NFEPE team that we work on does all our blog posts. And Doug's got a lot of blog posts kind of in this area. The latest one here is running Kubernetes without Docker using Cryo, Build, and Kpod. So that's a recent one. There's talking about CNI, which is the Container Network Interface,
yep.
And working through that where we're more infrastructure guys. We're not traditional strong network backend or NetOps guys or anything like that. So, and Doug said that it was pretty easy to work with CNI and going through that. We've also documented and going through and understanding GlusterFS. So that diagram that I showed with all the different layers, that came about with a lot of different iterations where we actually just had GlusterFS up and running because it was really an itch that Doug was trying to scratch. And so going through that, we've learned a lot about, if you aren't using Heketi and when you go to request a persistent volume through that interface, if that wasn't done with Heketi and you were just running GlusterFS manually, an operator would have to actually provision the persistent volume for you to allow a claim to consume it, basically. In this case with Heketi, when you go to claim and you say, I need some persistent volumes, it just goes through and it just creates everything for you. So we've iterated on that a few times to understand. So our Kube install has finished. Let's just do a quick look. So if this works, CentOS at Kube master. I knew that was going to fail. That's fine. Let's see if it works now. Oh, 5. Whoops. Oh, that's why. It's a new virtual machine, so kube control get nodes. Hey, everything's ready. So that's nice. Running version 1.7.5. 1.8.0 just came out.
Last Thursday, I think?
Yeah, so we ran into some problems with that last night, so we've actually pinned all this back to 1.7.5 currently. But so now we can see that that's all there. We got nothing in this directory. Normally we could do like get pods, cube control, get namespaces.
Yep.
So we've got default, cube public, and cube system. What we're going to do in the next step is create a new namespace called Gluster. We're going to create a storage class for Gluster and back it with Heketi. So when we request persistent volumes, it'll go into this storage class and we'll consume that storage class, which will then go and deploy all our data in the back end. All right, so let's do our Gluster install. This is the one that takes the longest because it's actually got to go deploy Gluster FS. It's got to build the LVM and create the bricks and the logical volumes and attach everything and then basically bring that in and instantiate Heketi. So it's got to download the Heketi pod. It's got to download the Gluster FS pods. So this part takes it's probably actually the longest part, but I mean, how long, 5 minutes, 7 minutes, something like that. And we technically have our Kubernetes cluster up and running right now. We just don't have persistent storage. So that's where we're at right now. So that diagram is basically everything up to wherever that went. So we've built all of this down here with the host, and we've built these nodes, these 3 nodes in this master, and we've attached to them, and we've made sure that everything's ready. So this last part is basically this green box, this Gluster FS. That's what we're spinning all of that up. We're instantiating a Heketi pod and allowing all of that to be attached and backed via our templates and things like that. So questions so far? This is kind of the part where interaction's good.
So wouldn't you want more of a pre-built system for production environment where, like
Yes.
you said, you install a Fedora and then you say, oh, I want Vim and this and that, and you have to download that stuff. But it's more possible for error because maybe that version's not available anymore.
You probably use an image.
Yeah.
You create your image and you instantiate from an image.
Yeah.
I mean, we're instantiating CentOS from an image, and then we happen to run stuff on top of it. Yeah. Or the other thing is you can just version pin them. If you didn't want to the right way to do it would be to run something like Spacewalk or Satellite. What's the upstream? I can't remember.
So Spacewalk is the upstream from Satellite, and that would give you kind of a path for booting your bare metal, where you could say like, hey, this is the image that I want to pixie boot on this machine.
And you have your own local repository, so you're not pulling off the internet, and you pull everything local, and then you can version pin all the pieces of software that are supporting the operating system and the application. So that's the proper way to do it. This is the quick and dirty way to do it, where I don't have to instantiate and automate myself a Yum repository. Right.
So we were starting on these virtual machines from a CentOS cloud image. So it's just a very stripped down CentOS. So you really have to install almost everything onto it. It's quite stripped down. It's probably like a couple 100 meg virtual machine image, but yeah, in a production environment, I'd definitely say.
And you would probably run your own, what's it called, the container registry?
Oh yeah, so another thing too, is part of what's taking so long during this step is that it's downloading container images. So in the next section, I'll talk more about how you create container images and what they are. But in short, you kind of cook the image like this is the base for this container is going to run. And typically you would put these into your own private registry that's local to your network. So when you go to download these images, they'll happen really quick. In this particular case, these are all public images. So they're all being pulled from a public repository called Docker Hub. And that's where these images are. So it actually takes a little bit longer. And this was intended to make for it easy for you to consume them publicly. And that's something that we may look into in the future, is extending this with a registry.
Yeah, there's definitely, we'd prefer to add some more automation to instantiate, a virtual machine that would handle all the images and build that down, so that when we're iterating during development and tearing down the VMs and bringing them back up, we're not constantly having to wait for 10 minutes. I mean, 10 minutes seems like a long time to me right now, every time you want to iterate. So it'd be nice if it was like a minute or two to rebuild the infrastructure in order to understand where I'm at and to rebuild that from scratch. So. And especially as you start to scale this, I mean, we're only doing 3 or 4 nodes, right? And it's 10 minutes. Imagine, I don't know how much longer it might take if you were trying to do 100, right? So, it seems like not a terrible amount of time, but as you start scaling out to huge amounts of numbers, 10 minutes can very quickly turn into an hour or two. And if you have to, spend that much time, then, it's just a waste of time of sitting around watching a console do this. Time's the next section at?
2:30.
Oh, perfect.
And
we're done. Okay, so we've basically deployed our entire system now in terms of infrastructure. We can look at the cube master, cube control, Gluster, get pods. We can see we've got 3 Gluster, and actually I can add O wide. So I can see I've got Gluster FS running across nodes 1, 2, and 3. So somebody's trying so hard to stop their ringtone right now. We are at a telephony conference, so it's going to happen. So yeah, we've got our 3 Gluster FS pods. We've got our Hacketti pod. They're deployed. We can see where they're living, that they're running, that they're ready. So now, you linked me yesterday the storage YAML.
yeah, absolutely. Let me get that for you.
I'm just honestly trying not to click on my chat because I don't know what's going to be in it. Let me grab that real quick.
I'm getting there. I just have to look at my gist.
Present safe.
Oh, you know what? Go to gist.github.com/DougBTV.
Whoops.
Oh,
That's probably it right
one.
there.
Yeah.
I bet you that's it right there. Boom.
Yep, that's the one.
All right, cool. We're safe. I can go back.
So what Life is about to do is to verify the setup that we have going on. So what he's going to do is he's going to ask Kubernetes to create a persistent volume claim for him. So
PVC, persistent volume claim. So the way it works is you ask Kubernetes via PVC or a persistent volume claim what you want, and then it basically goes and tries to satisfy that request. So I'm just going to copy all of that. I'm going to cat it into storage.yaml. The file doesn't matter. We have our file, and then I'm just going to run kube control, create file storage, and then we'll watch N1, kube control namespace. It's not Gluster actually.
yeah, it's in default.
Get PVC. It's already bound. So there's our volume. It's bound, called Doug Storage, and it's got a 1 gigabyte of capacity, and it's been living for 20 seconds. The storage class is Gluster, so we can actually look at that. So kube control, is it under the Gluster namespace?
I think it's,
I don't think so.
there you go. I think that it's
that's it.
across namespaces.
Oh, okay, yeah, that makes sense.
Um,
And describe. Does that work?
typo.
Oops.
Class E. at the
Oh,
end.
yep.
Yep.
So we can see that it's the provisioner is kubernetes.io/glusterfs. That's basically the glusterfs driver.
Yep.
The parameters being passed to it is the REST URL So that's where Heketi lives. This is the Heketi API, so we can actually test that real quick. Make sure that it responds. I think it's hello. Hello from Heketi. So we validated that Heketi is alive and exists, and that it's running, and we validated that the pod is running, and we've validated that we can communicate with it. We validated that, well, I mean, we earlier validated we can actually instantiate a persistent volume, which means that Heketi is definitely working. So we've got that far, and we even could run, I guess we could go back and look at, does this uses that?
Yeah.
Yeah, so let's look at this file real quick. I'm just going to pull it in.
So what Life is doing now is he's getting a resource definition that basically spins up a Nginx in a container as managed by Kubernetes, and it creates he wants to use a persistent volume. And that one would be under var www HTML, like it's your document root in a web server. And he's going to create that, and then he'll write some data into it just to verify that it can work. And if there's time, he can always restart the container, watch it come up on a different node, and then see that he's still got his data. So that'll have to pull down Nginx, which is probably 80 megs or something.
It's running.
Okay, cool.
I have a pretty good internet connection.
Yeah,
so.
it's a good one. Yeah.
So yeah, we've instantiated our pod. Let's describe it. Cube control describe pod.
My pod.
My pod.
Yep.
So this is the history of the pod, basically the events. Here at the bottom, the pod, the node, the IP address, container ID, what it pulled, what port it's doing, what its state is that it's running.
And it has mounts there, so there's a mount that's for var www HTML from a persistent volume.
I think you know what you want to. Do you want to just run the checks and stuff?
So actually, bring up the gist.
Oh, okay.
They're right in there.
Oh yeah, we just copy and paste.
Yeah.
Cool.
So
Yeah.
up there at the top, grab that.
So there's basically we ran these first two so far. We've created the PVC, the persistent volume claim. We've created the pod. I guess we can basically write some data into it.
Yeah, that's the one.
We can validate that the data is in there. So there's our testing 1, 2, 3 that we pushed into. We can delete the pod. I think I called it YAML.
Yep.
So cube control get pods. Just wait for it to terminate. Okay, pod has gone away.
And we'll just keep in mind that that was running on Cube Node 1.
Oh,
so,
good. Because it may come up on Cube Node 1. It may come up on a different one. Our storage is still here, so we validated the PVC, or so the persistent volume still exists.
And yep, and then you can create it again.
Oops, that's what we validated. I'm going to just run it again. I guess I could have just probably hit up. Okay, it's running. I mean, of course, it's going to come
Cool.
up fast because it doesn't have to download the image again. And then we can run this again. Let's actually describe it.
Yeah.
Cube control. Actually, we can just do get pod so wide.
Yeah.
Came up on node 1.
It came up on the same node, but by the same token, it's gone down and come back. So
it's been terminated. It's been destroyed.
if you're not used to running containers, it might be like, oh yeah, well I would expect that data to be there. But because of their ephemeral nature, whatever you usually write to disk on the container goes away as soon as that container is dead. But because we have the persistent volume mounted here, we're able to take the container down and bring it back up and still have the data there, is why that's of interest to us.
So, cool. That's 2:30. We're right on time for the next section. So, do we need a 5-minute break?
Yes.
Okay, 5-minute break.